Hello, so today we're going to take a look at Kotlin value classes. They were called before inline classes. So first let's just see the syntax and how you can define one. So um, GTM inline annotation and then value class. And then you can give the name and pass as a parameter to the constructor the value that is going to be wrapped and its type. One thing to note is you can only have one, it can only wrap one value. And let's see how it can be used. Usually it can be, the most important usage of this is distinguishing between different entities that have the same representation. So for example, you could have email that is represented by a string, and password is also represented by a string. Let's say we have this function here, auth, that needs two strings passed, username and password, right? So they have the same type, right? But the problem with this is that if you pass a password as the first parameter instead of username, the compiler won't notice, right? The compiler won't complain, right? So for example, here, this is the password, 12345 is the password, but I'm passing it as username, and I'm passing as password the username. So and because we don't have like a specific type for each, the compiler can check. And so this is where value classes are useful. So let's take a so first let's just run this. So so you can see it's saying authenticating as username with the password, right? So let's take a look at how we can use value classes to handle this better. So we can instead define two value classes, one for password and one for username, right? And now and each of them is backed by just one property, which is the value, which has a string type. And now our auth function, instead of just having as parameters two strings, it can have as a parameter the username, right? And it can have as a parameter the other parameter a password type, right? So you can see this is the username password and then the username value classes. Now to pass the username, we basically just instantiate. We call the username constructor and pass the username as a string and do a similar thing for the password. But the benefit is now if we try to do the reverse, try to pass the password as the first parameter, like we did, like the error we did here, for example, it won't compile, right? Because you can see here there is a type mismatch, right? We are required to pass a username, but instead we pass the password, so it doesn't compile. So we get type safety this way. And one thing also to note is that value classes help with performance, right? If we use just, let's say, a data class, we could also just use a data class username, right? But using a wrapper like a data class or just a simple class will introduce performance overhead because it will allocate memory for the wrapper class that we created. But with value classes, there is actually no additional memory used, right? Since it will just be using just this wrapped property essentially, and it will just unwrap the property, right? One question you may ask is, okay, yeah, this seems nice, but we also have something in Kotlin called type aliases. Can we use that? Can we use type aliases instead, right? So let's try that. Let's see if that achieves the same type safety that we got with value classes. So let's define a type alias for username and the type alias for password, and let's make these as parameters types for auth function. Okay, so the first call, we are passing username as username and password as password, so that's great. But the second call, because with type aliases we just still pass just the type, right? We just pass string, right? Even though the type here is the type alias, we just pass the value itself, and so we can still pass password without a problem as a username. And here we are passing as a username to password the username. So it compiles fine without any issues. So it doesn't give us the type safety that value classes gave us, right? And so this is this is a good example of when do you reach for value classes. So yeah, conclusion, type aliases don't really give us this because compile time safety, because it will let us assign the underlying property without checking if it's actually the correct type. Right? So yeah, so that's a basic definition of when to use and how value classes can help with type safety. Okay, so let's take a look at some additional properties or attributes of value classes. So we can actually have init blocks with some code that needs to be executed after a value class is instantiated. So let's say, for example, here I have value class negative, or it's just wrapping an int value, and if it has an init block so that it throws an exception when the value is not negative, right? So even additional type safety when the int value is negative is positive actually. So let's run this with a positive value, and you can see it crashes here. But if we pass, so it crashes here, that means that the init block actually run, right? And then if we pass a positive value, it should pass fine. Sorry, negative value. So if I pass -2, it works fine, right? The other thing to note is that let's go to presentation mode. Okay, so the other thing to note is that inline classes can also, sorry, value classes, inline classes is the old name. Value classes properties, value classes can have properties and functions. So we can declare properties and functions and have the init block, as I said here. So let's take a look at an example of properties we can have. So we can have only computed ones like this one here. We can't have properties with backend field. We will see an example later on. But we can have properties like length here, where every time we call it, it will be computed. We can also have functions like here. And so this is a name value class with a string passed. And so here we can call greet, and we can get the property value for property length. So if we run this, yeah, the greet works fine, and then we get the length. The other thing is that I mentioned when talking about this property here is that we cannot have backend field. Basically, value classes properties cannot have backend fields. They can only be simple computable properties. So like this one here. And so you can't have isolate in it, and you can't have delegated properties. So let's take a look at an example here. So here I have a property with a backend fields, this counter here, and you can see it doesn't compile, saying that inline classes cannot have properties with backend fields. So yeah, this is, you can do this for now. But properties with backend field without backend fields are fine. Yeah. Cool. So yeah, that's pretty much what I wanted to cover with value classes. Thanks for watching, and see you on the next one.